Going. This is Dr. Schulman, and I'm going to do a video on mathematical discourse. This one's going to be different. I've actually done a whole training series on promoting good discourse, which is kind of crazy. So I think the best thing to do is I'll do the intro one from the training video, and if you want to see the rest of these, if you're curious about seeing the rest of these training videos, guess what? Shoot me an email, and I'll give you a link to the whole series, right? Isn't that cool? So then I'll go through the assessment, all the pieces. Discourse, getting students talking, I think is really important. So I'm going to share my screen and get into it. So if you want links to these, they're in your course, or I could just email you. But we're up to mathematical discourse, which I think is one of the most important things. So I don't know. I had the slides here. I guess I did not save them, but that's okay. I have it right here. So I'm just gonna edit this. Yes, there they are. I just didn't hit the save button when I was working on it. So here's the training. This is the first day of the training. Now, this I made for a whole group of elementary school teachers who are having trouble putting discourse into this computerized thing called iReady. So school district brought this program iReady. I've used iReady before, so they asked me if I would help. Now, the best thing is I've got integrating effective practices, and this was the pre-work for the session. I had to watch one of these 3-7 videos. These videos are great. This has taught me so much. So developing mathematical inquiry communities. So this is from the Pacifica community over in Australia. And they did this amazing work trying to get students to talk. The biggest pieces of it was that they made you're just, as the teacher, just a facilitator. Everybody works in groups. They have great group norms. They talk through problems, and it's just really interesting. So these are free videos. They're really good. They've really helped me in what I'd like to do with education. So, and notice they have just about it, what the parents think about it, strategies for changing meanings, mixed ability grouping, doing a problem and launching it, learning how to listen, what to do with teacher development, the impacts it's have, group norms, learning for life, learning together, culture responsive pedagogy, fundamental shifts, and how to contact them. Now, I will play a little bit of it.
Education isn't serving social justice, and we've got to change that.
I truly believe, in fact, I know that everybody can learn mathematics. It's how you're taught.
The perspective I come from is that teaching and learning as it's currently done is inefficient to the point where you could almost say half of the learning capabilities of children are not being developed.
So when a teacher comes into a lesson, they have a maths problem that they know connects to a big, worthwhile maths idea. It's something that ultimately in primary school is going to lead them to do algebra at high school.
I'm getting to the later stages of my life, and I'm delighted that something like this is starting to emerge.
This pedagogy actually works. In one of our very first PD lessons, when we followed Bobby into one of our own classrooms and she demonstrated one of the lessons, our thinking shifted for what our kids could do.
To see it in action happening in one of our classes where the children had no idea who she was and no idea what this kind of problem-solving maths was, and to see it work successfully, that was really powerful.
I'm going to pause it right here. But you can watch more about it. I think it's just a really great resource. Notice that only one student's holding the pen. So they all have roles and jobs. So only one person holds the pen. They come up with different ideas of how to problem solve. They make sure all the problems have to do with things in their life that are realistic. And then they go up and show. So the teacher lets the students show different ways of solving the problems. So it's just a really interesting way to approach mathematics and just kind of redefine the way your classroom looks like. So I think that's a good way to properly present it. So what did they do in this training? They had to watch 3 of the 7 videos, the intro, which we started grouping, learning to listen, teacher development, group norms, learning perspectives, and culturally responsive pedagogy. So they had to watch at least 3. They're all between 2 and 7 minutes long and discuss it. And then they had to read about iReady. Now, iReady is this program that a lot of schools use, but the best things about it is these are interesting practices that they have. So try it, discuss it, connect it is one of their big approaches. So it makes sense, solving and support, share your thinking, compare, make connections. I think that's really smart. So the main things that they have are individual think time. So really letting students like pause in the moment, turning and talking, which is great. And then the 4 R's. Teach your students how to repeat, rephrase, reword, and record to really help students have a place in the classroom. And then it goes into how you can do this. And you have access to all of these. So, and common mistakes that we all fall into as teachers. All right, so this was the Discourse program I ran when I was working over in New York. This was introductions. I use Jamboards all the time. I don't know if you've ever seen a Jamboard, but I just think they're great. Everybody can write about it. Like, what does discourse mean to you? They're able to like put it on. We could all see it together, just like an interactive whiteboard. And yeah, let's keep it going. So there's a bunch of definitions of what discourse actually is. So I like talking and acting in ways that are mathematically competent, and people talk and act when talking about math in the classroom. That's one I like. iReady says it's explaining their own thinking, listening to and evaluating the approaches of others, and making connections between different stages. Then we've got NCTM, and they say that encourages teachers to facilitate discourse among students as an effective practice. It's building shared understandings of mathematical ideas by analyzing and comparing students' approaches and arguments. So I think that's really great. So this is some stuff that I got out of all the stuff about the developing math inquiry communities in New Zealand, working with these Pacifica students. So I really like the group norms. So one student holds the pen. They really like disagreements and like they encourage them. So they always say you're disagreeing with the idea and not the person. I think it's great. There's a shared responsibility of learning for all students. There's no leaders, there's no passengers. Everybody is active. This one's great. The teachers are not seen as experts, but a member of the group learning together. You don't understand how many times I've stood in front of a math classroom and people are just looking at me. It's like, how do you do it? Like, what's the best way? Which way do you prefer? If I'm showing multiple strategies, but we should all be learning together. And you should really try to promote that in the students. There's stuff that I don't know, and I'm okay with admitting that. There's stuff that your students don't know, and there's always a different way to see something. You're always trying to have the students take ownership of their learning, taking chances, making mistakes. So definitely taking chances to making mistakes are really big, instead of just jumping in to provide the answers, and building understanding by critiquing politeness, friendly arguing, challenging, and explaining. Okay. So these are their benefit. These are the iReady strategies. So think time, turn and talk in the 4 R's. There's definitely benefits and challenges to this. Really think about how you can do it in the classroom. So what are other ways? Like, how do we actually do it? I really like this one, sharing our math ideas. So what are different forms of sharing your math ideas? And this is the link to this poster if you want it in your classroom. You can listen. So you're looking at the speaker, focusing, thinking, and being open. What are ways we can talk? Use the math words, right? We want to learn how to speak the same language. Ask more questions. Use a strong voice, and with a partner, make sure you're using a quiet voice. And these are just hand moves. You can create your own, like, so students don't have to say anything. It's like, I have an idea, or I agree, right? The chakra, or I disagree. So just, you don't have to speak to communicate. All right, so here are stuff that I found throughout a bunch of places. You could have these as handouts, you can make them as posters. So this is one of the big ones I've seen a ton. So I agree with you because how do I know your answer is right? My strategy is different because I've seen these on desks in students' classroom. So it's just other ways to help them have a way to speak. Give them those cues to speak in the classroom. And I think the images are great. This is from another teacher who does a great job. She made these, and this is a link to all of her stuff. But it's like, so I see you're saying that. I understand Beatrice is saying. So these are ways of revoicing, repeating, and reasoning, adding on, giving wait time, and revising thinking. And because I'm always going to share resources, they have cards. They have talk cards for iReady. And so could you explain problem solving? Do you see any patterns? I started problem by solving. So there's green cards to make sense of problems, blue cards to help students verbalize, purple cards to help students reflect on what they did, and red cards to help your students respond to questions. If you click this, you'll get access to all the cards. So what would you use? Would you use these? Would you not? Okay, so this I got from a bunch of different pieces. Basically, it's from NCTM, and this was from I asked if I could use it. It's from a presentation on Discourse that I thought was really well done. So this is facilitating meaningful discourse, and you can look through it if you'd like, but they do a really good job in here of just explaining different things about discourse by the National Council. So what is your role to engage students in tasks that promote reasoning and problem solving and facilitate? You want to create lessons and activities that actually make students talk to each other. All right, so then what are things that you can do? You anticipate the response, you monitor their work, you select particular students to present their work. Sequencing is good. You can connect different students' responses and connecting the responses to mathematical ideas. And we facilitate discourse by building a shared understanding. So I think the main idea for all this stuff is how do we make students have a shared language? Because you should really think about mathematics as learning a language. So what's the best way we can do that? So students learn to articulate and justify their own math ideas, reasoning, their and others' mathematical explanations, and provide rationale for their answers to develop a deeper understanding, and that's critical to their success. So all that stuff is good. And this was just the homework. So there's other sessions of this. This was a 4-part series. If you want to learn more about the Pacifica group, this developing math or inquiry communities, these were a lot of the papers that came out of it. And this was the research that found it. So this is research that came out of it and how it was built. So these are the articles that came out of those sessions, if you want to look at it. And this is how you can do it from the technological standpoint. Now I've got a ton more of these, for the series, but I only wanted to show you one, so nobody was overwhelmed. But if you want to learn more, just let me know. All right, so let's go into the actual assessment itself. So it's all right here. But I think discourse is really important. That's why I wanted to show you that one. So this is the thing I always tell new teachers. However, students engage in academic discussions only 2% of the school day. I know that was like over 10 years ago now, but your students are only talking 2% of the time. That's a problem. That is a problem. So we should really think about ways. Sorry, let me turn off my phone. We should really think about ways to promote it and really do great ideas to promote it. I'm a big fan of Vygotsky, so I wrote an entire piece on it. But basically, the symbolic tool of language was essential to transmit knowledge. So language, we cannot learn. Basically, this means we cannot share knowledge. We cannot teach unless we speak the same language. So having an agreed upon set of terms allows for explanations, justifications, and descriptions of math content. In order to teach concepts effectively, the instructors and learners must utilize these consistent sets of language tools. Only then can productive comprehension of terms, descriptions, and questioning takes place. Vygotsky explained the benefits of a shared language of terminology, symbols, and numbers by drawing connections to what we already know. Within this social sphere, a common and agreed upon language provides the methods for individuals to learn from one another. All right, so many of the next I stole from this 2023 virtual presentation by Coddington and Kula. I watched them do this. They did such a great job. This are their slides. This is the one I was talking about that I stole. The other one was just from NCTM. So they did just such a great job of building math discourse. I actually really like the same definitions, and these are habits of the mind, setting norms, making an emotionally safe classroom, normalizing error. All these stuff is really important. So graphic organizers, and so these are just ways to build it. All right, let me get back into where we are. So a competent way to share and express content through speaking actions. Promoting beneficial math discourse and discussions can benefit from focusing on student assets, employing strategic grouping strategies, emphasizing visual and symbolic connections, using relevant experiences, scaffolding sentence starters, creating opportunities to pre-learn and vocabulary. I'm going to give you just a bunch of strategies I do, like give them a chance to cap the language, push vocab. My students hated vocab, but I made giant word walls and I had them do it all the time. So this is other ways you can do it. How can we make sure it's fruitful for our learners? You got to set norms and expectations with students. So a lot of students are frightened to speak at class due to negative experiences. So a lot of times these students, they come into the math classroom, they're not sure what to say. They think they're bad at it. They lack confidence. If you set norms and help provide ways to build confidence, so that's either normalizing mistakes, listening to others, giving them sentence starters, all these things can really help. State the principles of good math discussions is an emotionally safe classroom with challenging tasks, multimodal representation, and academic language. And then I talk about this DMIC group. So this mathematical inquiry, basically based on Dr. Bobby Hunter in Stanford. So this mathematical inquiry groups in New Zealand was based off of Bobby Hunter's Stanford ideas, which came from Cohen, Lowton, and Bowler, and collaborative inquiry of staples. So I always want to show you where this stuff comes from. So if you want to know exactly which built this idea, these were the articles that kind of built it. So they treated the community that values the class as a collective family instead of a team competition. This idea really kind of blew my mind because I'm huge on competitive. I do games all the time in my classroom. My students play against each other. They play games like tic-tac-toe against each other. They do Jeopardy groups, they do worksheet races. All this stuff is competition, but it really had me step back, and instead of competing, making it a collective family was a big piece I took out of it. They also challenged teachers to be facilitators, where students work as groups and sharing perspectives instead of directly instructing the students how to solve problems. So your job is to provide the help. And this is another great point. So you're not actually telling them how to do it. You're giving them the problems, you're giving them the tools, but they figure it out. I make that mistake all the time. I just tell people how to do the math instead of giving them the opportunity to learn how to do the math. It tends to make it stick better. So they guide the students and let students teach each other all the various ways to approach the problems. You can watch the videos. I think they're great to see how group norms and talk moves make fruitful communication. So I think all this stuff is just really useful. I think it's just really useful for how to make changes in your classroom. There are no experts. Everybody's in a group, taking a chance of making mistakes. So I know I kind of spoke about it before, but here we go. So this is what you have to do for this assignment if you'd like to do the discourse one, which I think is really useful. So I want you to get a chance of seeing where you can put discourse in. Are you going to do it at the beginning of the lesson? Are you going to do it during the lesson or at the end? So these are just a bunch of ways that I've used discourse. Is it all the ways that are out there? No, right? But I think it could seem like a big nebulous idea until you're really trying to put it in. So how can we use it in an introduction? So without knowing the vocabulary symbols of the content, students may be lost before they begin. Before jumping into the steps, educators can provide vocabulary terms and symbols that will be covered to give students an idea of what they are learning about. So how can you do that? Is this one of mine? Yes. So these are all vocab lists that I've made. There's tons of them. So what's one way we can do this? Let's see a vocab list. Hopefully it's not too bad. But look how many vocab lists there are, right? We'll see if it actually opens. Yeah, so here's a very simple week one of a vocab list. It's on decimals, fractions, and percents. They can use this website to find the answers, and these are all the words I want them to know. Least common multiple, greatest common factor, denominator, blah, blah, blah. And I want a definition, a symbol, or an example. And guess what happens at the end of the week? They do a matching quiz on all the words. And you have access to all those quizzes if you want to use them. Okay, let's get back into it. So that's one way. And this is what it looks like. So I showed this lesson before, but the do now of a lot of my lessons, they have to copy this down. That could be the do now. So they don't have to look at it themselves. They can look it up themselves, or they could copy it down before it happens. Function, one-to-one function, vertical line test, horizontal line test. This is what they need to be successful in the lesson: domain, range, composition of functions. And what do they have to know? This is all the vocab that we'll be talking about before the lesson starts. We could also do other types of vocab pages where they do definitions and diagrams. This is a geometry one. Okay, I don't know why it's over here. I'm going to close that. And then you could also just provide them the definitions, right? So you could just give the students all the definitions beforehand if you don't want them to do it themselves. I like them writing it in, but if you want to give them all the definitions, you can. This is one that's in English as well as in Spanish. Okay. Either way, students are prompted with knowing the definitions of terms that are being covered. Another option is to create a running list of all of the math vocabulary needed and necessary formulas. I've done these word walls tons of times. Here's just a link. Mine were always like really big posters, okay? Mine were all really big posters that kind of look like this, but it was on a poster. So for compound interest, whoa, I don't care about your blog. It would just be a poster that has the formula and every piece was here. I had one that looked just like this for compound interest, but mine was simple interest, compound interest, and then continuously compounded interest. There were 3 on my poster. And I had my students help me make them after school because I don't have the best handwriting. I'm sure you're all already aware of that. The word wall is a great place for complex formulas too. Like if it's a geometric sequence or series, they never know those. Instead of providing vocabulary, students can be given a written introduction to read. So here's part of that book from Alcosi that I think is amazing. Instead of vocab, they can read about the person. This is a great way to incorporate discourse, is a reading out loud about the mathematician who made the topic they're learning about. Math may not be students' preferred discipline. Oh, sorry. That has the history. And this historical and English-based approach can give students different pathways into the math class. Short biographies with critical thinking questions can humanize the content and add necessary context to help students learn about the creators and why it was first created. These examples have critical thinking questions applied. You should push students that there are no wrong answers. I use think, pair, share for those. However, ensure students are using proper sentence structure, word choice, punctuation, and math vocabulary in their responses. What are other ways to do it? You can do a video introduction about who is Pythagoras, or what was this one? Just use a video of a biography or a group of people. Okay, so this is a video introduction of, my students love this one. I think it's in the project-based learning thing, but basically they watch how the pyramids were made, and they learn about the ancient Egyptians. And then they get to measure themselves as if they were the pharaoh. And students really like this because not only were they able to create giant images of themselves with this, but they also, excuse me, they also were able to show that it really helped a lot of girls who had body issues because they were measuring themselves and they found out like certain parts of their bodies were in proportion, whether it was their ankles, their knees, and things like that. So it's just a really good lesson. You can see it in the project-based learning where I go over it. This one is great. So I've talked about it, the which does not belong. And this is a mathematical debate strategy. You show four images or symbols or math expressions on the screen at the same time. Students are instructed to walk to the corner of the room that they believe the item does not belong. And I always signify what part of the room it is for each image, like in this slideshow. I made this one for history and English pre-service teachers, and they loved it. You can see theirs was words, like which words are different. Earn, find, him, links. You can see that these are all homonyms, and bear, be, for, hour. And then I have which one doesn't belong, Renaissance, wall collapse, Salem witch trials, discovery DNA. And they got to debate which one is different and move people to their sides. This research shines as an informal pre-test element. Students reveal how much they do or do not know about the items, and this allows for focus, where to focus teaching efforts, especially to shore up the gaps of, so if I'm doing a which does not belong, and this, I always make them myself, but these are all already made, you know, you can do the ones with shapes. If the students don't know about equal sides of angles, internal angles, rotational order symmetry, whatever they're saying, whatever they're missing, you'll know where the gaps are, right? I think that's a big piece. So this one's just shapes. And I think it's really nice. So and people share theirs. Okay, let's keep it going. Another introduction activity is fraction talks. Now, I've done fraction talks a bunch, a whole bunch. I think they're great. So fraction talks is you give a student a shape and you can make this as challenging as you like. So I might as well show you one of these in action. I think I have it on that Jamboard. So for the fraction talks, I usually have it on an overhead projector and I color in a piece and it's like, can you find all other sections as the same shape as? Can you find all sections that represent, I don't know, like a third or a fifth? If the shaded section is worth some like 10, how big is each section? What other possible fractions can be shaded? So all these are great. All of these are really good. And they have the images, right? They have all the images. So let me go to the Jamboard. I know I have some fraction talks on there. Here we go. So this was ones from that discourse I did, and students had to figure out which one does not belong, and everybody played. Even me, I thought that one was different. So I think these are really good ones. I've used these before for elementary school trainings where people had to figure out where it is. I guess I should save this. Might as well. Because Jamboard's going away. I said might as well download it. Okay. So here it is. So here's a basic fraction talk, right? I colored this in. Everybody has a piece of this shape in front of the students color this in. Then you ask them the questions. This is 5. How much is the whole piece? Right? Can you color in another part of this that represents this amount? What is this out of the total? You could say if the total is 200, how much is this piece? There's just so many different things you can do with it. Then I would do it with this one. I'd color this one in and be like, name what does this represent? How much is this out of the total? And all those questions will go well. But that's how I would do it. And then I have another shape. How much is this? You can just start with like, what is the fraction? But that doesn't really help people talk. And then I have some other shapes. And there's tons of them to use. Okay. So let's keep going. I think fraction talks are great. The shaded section is worth blank. How big is each section? If the total area of this shape is blank, what is the area of the shaded section? I think that really helps students. One way is to print out a series of the one shapes for all students and then have one on the overhead projector, shade in the one section of the shape, and pose an open-ended question such as the ones on the website. You can also shade in this section, have students come up with the questions themselves. So I like that even better. Like I color it in and be like, well, what questions can you answer based on this? So all of those are intros, right? I think all of those are intros. Are there other ways to promote discourse in the beginning of course, but these are the ways that I've done that I found were effective. All right, so how do we do this during a lesson? So while the lesson is occurring, there are many ways to promote fruitful math discussions. Partner work, where students share on whiteboards is great. They write it down, they share answers on whiteboards. You can arrange desks to have each student's work as a pair. I've done pairs, I've done quads, I've done triads. So 4 desks together, 3 desks together. Teams or grouped activities, whether it's for review, there's Jeopardy labs, or a modeling eliciting activity, are great ways to promote positive discussions. So you can use Jeopardy, here's one of mine, or Quizlet as a review. I don't know if you've ever used Quizlet before, but it's great. Why do students love Quizlet? Because they get to be grouped as animals and they get to move around to meet with each other. And there's only one right answer on their phone, right? So only one student in the group has the correct answer on the phone, which means they have to talk to each other. Yeah, I wrote it right here. So modeling illicit activities, if you want to see some of mine, are open-ended problems with a variety of solving methods. So here is a modeling eliciting activity. I showed them a clip from San Andreas. Here's the problem. An earthquake erupts, 18.68 million Los Angeles residents, only 20% remain after the devastation. Your team is part of the relief effort charged with providing enough water to the remaining survivors to live off for the next 2 weeks. How much water will you bring? So I think that's all really important. So you have to figure out how you're going to transport it, what size you're going to use, how much water people drink every day, and how you're going to get it there. So I think all of this stuff, and this is how to figure out how many people survived and certain information. So that's a really good way to have the math problem using modeling. All right. Other ways, you can set up competitive activities to promote discourse or having opportunities to write, speak, and read. Enabling more writing experiences and reading can lead to more positive discussion since they know what the words are. They're speaking the same language. You can insist on using math vocabulary. One simple way is to write the justification for each step. So that's the PEMDAS one I showed you, the linear algebra where they have to write each step. And they can use this in formal proofs as well. So they get a sense of what they are doing and why. Another method could be having students justify their answers through writing. Students will explain why they believe their answer is correct or make sense using math vocabulary. So this is the biggest piece. I try to always give my students the math answers, and their job is to explain why it's right or tell me why they got that answer. I think that's more important. That justification is so big. So, especially when we're dealing with things like word problems. What a surprise. My students started with a vocab quiz. This is old, but that's fine. The first thing they have to do is this is all of the words they can see. So product, half, difference, increase, twice, less than. So less than is after the fact. So that's if it's less than, it's like two. If it's less than x, like 2 less than x, it's x minus 2. But if it's 2 less x, it's 2 minus x. So the then is after the fact. These are all the words that they're going to need: consecutive, supplementary, complementary. The product of 7 and a number is increased by 3 and is equal to twice. I might as well download this and do one of these and show you how it works. I'm always going to want to show the math as we do the math. So product is, I gotta go to draw. Product means multiply. Half means to divide by 2. Difference is subtraction. Increased is adding. Twice is 2 times x. Less is, we can say it's 2 minus x. If it's less than x, it's x minus 2. That's big. More is like plus. So that's like 2 plus x. More than is x plus 2. Sum is adding again. Length is a distance. Okay, so let's look at some of these. So the product of 7 and a number, so they're multiplied, is increased by 3, which is equal to twice the number, so twice that same number, which is x, subtracted from 39. So I made a mistake. Subtracted from 39 means it's 39 minus 2x. And then I would have them also say the steps they're doing. So this is given. The first step is adding 2x to both sides because that is the addition property. It's the opposite of subtraction. So always leave your x on the left-hand side. You should always also write the reason why, not just add 2x. We're going to minus 3 to both sides, the same thing, which is the additive property. So I'm left with 9x equals 36. And then this is the multiplicative inverse. So we're basically dividing by 9. So x equals what? 36 divided by 9 is 4. And then you can check. I'll just set up one more of these. So 5 less than twice a number, so that's 2x minus 5 is equal to 1/2 the difference of 1/2 the difference of 3 times the number. So it's 1/2 the difference of 3 times the number and 13. So this is the difference of 3 times that number and 13. To solve this, I would distribute first, and then I'd solve. If you don't know how to do that, it's 2x minus 5 equals 3/2 x minus 13 over 2. I know they're fractions, scary. If you want to make them decimals, we can make this 1.5 and 6.5. It's up to you, right? So minus 1.5x. I'd rather have it as the fraction, but I know people hate fractions. So this is 2 minus, it's 0.5 or 1/2 x. Minus 5 equals negative 6.5. Add 5 to both sides. I'm left with 1/2 x equals negative 1.5, or we can write it as 1/2 x equals negative 3/2. The opposite of, we could do the butterfly thing, cross multiply, right? So that's 2x equals negative 6, divide by 2, divide by 2, and we're left with x equals negative 3. Another way we can do this, 1/2 x equals negative 3/2. Since this is 1/2, we can multiply both sides by 2. Those cancel. We're left with x equals negative 3. Either way, we're gonna get the same answer. Ta-da! One more. One number is 9 more than twice another. See, it's more than, so it's twice. One number is, so is equal. One number is 9 more than twice another number. So there's y. So there's 2y plus 9. One number is 9 more than twice another number. The sum of the numbers is 129, so that's x plus y. The sum of them is 129. Ta-da! So there's a bunch of ways to do this, but since I'm going to use substitution, I'm going to drop that in. 2y plus 9 plus y. See, I replaced the x with this piece equals 129. So I have 3y plus 9 equals 129. Minus 9. So 3y equals 120. Divide by 3, divide by 3. Just going to have the 0 here so I don't have to worry about it. 12 divided by 3 is 4, so y is 40. And so if y is 40, well, what's 129 minus 40? That's 989. So x is 89 and y is 40. Ta-da! If you want to do the rest of them, you can. But I think that's why learning the words, speaking the same language is so important. Okay. In addition, students write QED or quod erat demonstratum, which is demonstrated as it's been demonstrated to end their math reasoning, such as mathematicians would do in formal proofs. So you can really treat them like mathematicians, like Bruner would, or Dewey. Dewey's experiential model to treat a student like a mathematician takes more ownership of their work. Other methods. All right, what other methods do we got? Math Talk is to provide them with tangible resources. So you could either give them these sentence starters. Ta-da! Here's a bunch of sentence starters you can give them, which is nice. You could also give them the graphic organizer that's here. I always do this. This one's fun. Turning their own images into word problems, I think, is super fun. So this was one that I did. So they draw their favorite geometric shape on a blank page, use whatever they want. And they pass the paper to the person in front of you. If you are in the front, pass it to the person in the back of the row. So you're working as a row. Turn that geometric shape into a real-life object. Then pass the person in front of you. If you're in the front, give it to the back row. Then you draw a scene. So you go from triangle to pizza to Scooby or a cat eating the pizza. Then, if you're in the front, turn the scene into the math problem. So Mr. Shulman eats 6 slices of pizza in 10 minutes. How long will it take him to eat 3 pies, 8 slices in a pie? And then what do? Pass the paper in front of you. Solve. If you're in the front, pass it in the back of the row. So how does it work? 3 pizza pies, 8 slices of pie. So if I can eat 6 slices of pizza in 10 minutes, 6 over 10, how will it take 3 pizza pies? So 3 times 8 is 24. You cross multiply. It would take me 40 minutes to eat 3 pizza pies. I must have been really hungry. So that's just a really simple way. I really like doing stuff like that where students can just get to create their own problems. Of the vocabulary guides mentioned above, students can feel more confident speaking during the learning activity. In addition, targeted discussion based on, you can have them make anchor charts. We've never seen an anchor chart before. They just have all the different pieces. Oh, here's are just fancy ones. To me, an anchor chart is like, has all the pieces you need to do it. Let's look at one of these as an example. These are fun. Measurement conversions, line plots. These are nice. Mind maps. I've done mind maps a lot. Here's 10 examples. Whoa, of mind maps. So we have this one. So there's trigonometry ones and stuff like that. So here's a mind map for trigonometry. However it makes sense for you, right? I like think, pair, share, spectrums. This is just like a virtual whiteboard that I've done. Could post where they saw themselves as progressive or traditional math educators to spark a discussion on teaching philosophy, as well as they could post questions or comments and feedback on reading Dewey's book. And I always place myself within this as well. I always try to place myself within these. So here it is. These are a few of the students. Are they traditional or progressive educators? I might as well just export these Jamboard files. What a shame, no more Jamboard. Okay. Well, I'll have to download these, but this one worked really well. Okay, so I like doing the, like spreading it out, right? So I might as well just download this one. I won't keep them all, but I might as well just download a couple of these. Ta-da! Cool. All right. So the reason why I like this one a lot is because I got to place myself on this thing, and then the students got to put themselves on the line too, and it just helped us talk about it by where we were in here. It's just like a way to start a conversation. Are you more traditional, more progressive a teacher, and why, right? Okay, so closing is usually about discussions at the end, right? A good way to conclude a lesson is a discussion providing about what is learned, having students understand the concepts and what they're still struggling with. So providing this class time where they can ask questions and like really close up a lesson is really good. A lot of times you can use a totem. I used an inflatable soccer ball because that's what we used a lot, and that would just make sure only one person spoke at a time. You can use like a meter stick or whatever you think is good. Why'd I use the inflatable soccer ball? Because it has a bunch of hexagons with ample space for numbers. Just by having the totem ensures that only one person talks at a time. And you can look about the closing discussions I did in this lesson if you want to see an example. Other ways to promote productive discussions is to have a writing component in the class or the unit. So this is how students can reflect on it. So this gives them a really good chance to write about what they know, what they still need help with, how are they going to get this up, what was their score, are they happy with their score? And I got students to be able to do this because if they completed this page and tell me what's working for them or not working for them in the class, because they got to rate everything in the class, then they were able to do corrections for half credit. Students can also be given the opportunity to rate and share what they feel, right? Which is good. Oh, so this is another thing that I've done. Students can just give me full feedback on whatever they're doing. So you can do it on paper or you can make a Google form. What are things I learned? What am I confident about? Rate the lecture's engagement, rate the lectures, talk about educational technology. If I were to make the lessons, what would they look like? Really give your students a chance to give you that feedback to get better. Other ways to promote good discourse is to assess students' ability to understand the vocabulary through matching quizzes. Yay, I told you I'd show you one of these. I've got hundreds of them. So, 0 solutions for quadratic. There's always, so this is going to be the roots. Ta-da! A rational number multiplied or a factor multiplied by itself. 3 squared equals 9. I believe this is a perfect square. Method for solving for a quadratic, divide by 2 and square it. That's the completing the square. This is the quadratic formula. And part of the quadratic formula gives you about the roots. That is the discriminant. So just simple, 5 points. Shouldn't take a long time, but this is Unit 2, Week 3 vocab quiz. And that's what it looks like. So I would always do that. Have I done a big vocab test before? Oh, yeah. So here's a big vocabulary test in self because there were so many words to learn for geometry. There's pictures and pieces. So 90-degree angle, that's the right angle. So 20 is G. And I've also made a super long one as part of the semester exam where they had everything that they learned, right? Every single piece. So they had to match the vocab to this. So I've done huge ones. In addition to homework assignments where students have to write about the methods they prefer, or projects where they require them write answers and talk about which data displays makes the values easiest to understand or support their hypothesis can all lead to math discussions more productive in class. The more practice you provide with writing about math, the more comfortable they will become speaking it. It's just my idea. And so what do you have to do? So I just gave you a bunch of ways to do discourse, right? The assessment requires you to rate the usefulness of math discourse strategies employed across different parts of one lesson. You must describe whether you believe the strategies applied would be able to promote positive math discussion, as well as the ability to understand the concepts being taught. So you're provided with the lesson plan. It's the Finding Footballs one and the slides that go along with it. So you get the plan, you get the slides, and then you get to make your judgment, right? The lowest level challenge and the 5 signifies the highest level or most optimal. After reviewing the lesson, you are challenged with selecting your own content standard and devising at least 3 strategies to promote math discourse using the introduction of the lesson, the teaching activities of the content, and the closer. And then I want you to reference some journals to back up your thinking. So which one does not belong? It's the intro. Is it a silent room or a loud crowd? So how much discussion would happen? Why did I pick it? This one is the ability to promote comprehension of the standard, lower learning, or high success. And why did I choose that value? So the first thing is they do the which does not belong. Then there's a symbol breakdown. So they get to learn each part of the symbols. Then they get to hear about the history of the content. Then they get to talk and play the spot the ball game where each person is literally directing each other. So they have to touch on the screen. So everybody on their team is like to the left, to the right, up, down. I guess I should show you what I mean by that. So they start with the which does not belong. Then what else is talking? Where do the words come from? So they all get a chance to speak about where this word percent comes from, and we do the same. Then they get the history piece, so they get to hear about the history of them. And then it's the game. And so the members from their team only can help determine the placement of the missing ball. So what happens in this game? So here's the game. So let's say it's this one, and you're talking, just one person's up at the board, they're moving around, and your team is saying to the left, up, down, right, left. It's a good guess, better than 80.72% of people. The ball's right there. And I picked there. If you get 90, it's blue. Fancy. If you get less than 50, it's red. Okay. So then they do open-ended questions where they work together in groups at stations. They do a think, pair, share discussion. Then they have the homework assignment where there's a writing piece. There's a writing piece of the homework assignment. All right. So this is the first thing you have to do. The next thing is define math discussions and math discourse, either citing or providing your own definition. What are the inherent benefits or challenges to incorporating math discussion in the classroom? Describe the process of setting norms. Explain your role as a facilitator. Describe how you will hold students accountable for participating during the math discourse. Are you giving participation grades? Then this is the big piece. You select the standard from the Common Core, right? Or from this, I should put select the grade and content standard. I should have a Common Core in here. So I made this in New York, so I might as well have Common Core in here too. It's in all the other ones. Here we go. With a math discussion strategy, then you just make an introductory activity. Explain your direction details. What would you be doing? What the students are doing? How does it promote? So basically for each of these things, how does it make students talk? And how does it help them understand the content? And then how you're describing detail for one strategy for building. So you describe your plan. Again, for during the lesson, how does it promote mathematical discourse? And how does it help understanding of the content standard? And the same thing for the closure. So just explain the directions in detail. What are you doing and why? Then finally, do you plan to have discussions in your classrooms? Explain what it was like to complete the assessment. Did any of your thoughts about math discussions change? Describe ways to improve or alter this. And if you were to create this for pre-service teachers, what would it look like? Here are all the standards that it covers. So I know this was a long one, but I thought it'd be really useful to show you everything. And here is the rubric. So this one is only 15 points. So the first one is rating the lesson strategies. So where you're clear and detailed in your rationale, why the numbers you picked, understanding how it does what it does. For the intro, do you have a good definition and how you would use it in your classroom, like the strengths and weaknesses? Then how were your discussion strategies, right? So were they solid? Were they reasoning? Reflect on it. How's your reflecting? And was it formatted well? So I hope this one was useful. I know I had a lot to share, but I'm excited for you to rate what you think of the ones that I do and then have you try your own. So enjoy your day.